Good morning Year 5. Today we're going to be adding fractions with different denominators using lots of skills that we've gathered together over the last 2 weeks. Let's have a look at what the question's going to look like using the slides. So to begin with, we have first question. Complete the calculations shown below. 1/3 add 4/9. Well, we know when we're adding fractions that we have to have the same fraction family on our denominators. They have to have a common denominator. They must have multiples that they both divide exactly into. If we look at this fraction, these two fractions, we can see our largest one is 9ths. Does 3 go into 9? Is 9 a multiple of 3? Yes, it is. So we don't have to change this one, we just have to change this one. So we're going to keep our 4/9 and we're going to turn this fraction into 9ths as well. So what have we done to our 3 to make it into 9? We've multiplied it by 3. 3 times 3 is 9. If we multiplied our 3 to get 9, we must multiply our numerator as well. What we do to our denominator, we must do to our numerator. 3 times 1 is 3. So my new fraction is 3/9 add 4/9, which hasn't changed. We've got the same fraction family now as our denominators, and we can say 3 add 4 is 7. So I have now got 7/9. And we can check that using the diagram. We had 1/3, 1 out of 3 coloured in, and we had 4 out of 9 coloured in. But because they go into the same multiple, we can divide this exactly into 9ths as well, and we can check our answer. So we have now got 1, 2, 3, 3/9, which is what we had converted our 1/3 into, and 4/9, which we didn't change, we had originally. 1, 2, 3, 4, 5, 6, 7, 7/9. Complete the calculation shown below. We have completed the first question, and that is a model of what some of your questions will be like. Let's have a look at another question. Question 2. Complete the calculation for this model. This model shows us some amount of fifths, our numerator is missing, plus 5 and our denominator is missing. Now we can do this nice and easily because we've got the model. We can see that it's 2/5, 2 out of 5. So we can put our 2 in, and we can see 1, 2, 3, 4, 5. Our 5, our numerator is done. But what about our denominator? How many have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So using the bar model, we know we've got 5/15. Now we need to find the family, the fraction family that we can use as our common denominator. First of all, let's think about 15. 15 is our largest denominator. Does 5 go into 15? Is 15 a multiple of 5? 5, 10, 15. Yes, it is. So we can turn this fraction into 15ths. How many times will we multiply 5 to make it 15? We'll multiply it by 3. So if we've multiplied our 5 by 3, we must also multiply our numerator by 3. 3 times 2 is 6. So let's cross that one out so we don't get confused. Now we've got 6/15 add 5/15, and we've got 11/15. Lovely. Can we check that? Yes, we can. If we make this into 15ths, it should give us our answer. Please excuse the computer not being very accurate. You can do it much neater than I can. Have we now got 6/15ths? 1, 2, 3, 4, 5, 6. Yes, we have. If we add them to this, 7, 8, 9, 10, 11. We have now got 11/15. Complete the calculation for this model. we've done that. Let's have a look at our third type of question. So another type of question you're going to see is one of these. Nice and straightforward, but it's differently phrased. Shade the model to complete the calculation. So we want 2/3 coloured in. 1, 2, 2 out of 3, and 3/12. 1, 2, and 3. And we've got to add them together. Or we could look at it this way, and we could make this into 12ths and work it out this way. And then we can double check it with calculating instead of doing it the other way around. Let's have a look at this. I've now got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8/12ths on the top, plus 1, 2, 3 on the bottom. 8, 9, 10, 11. So my answer is 11/12ths. I've used the model and I've shaded it as asked. In fact, I'm going to shade that slightly better so that it colours it completely for you. But is it correct? Let's double check. Let's have a look. 12 is our largest number. Can we use 12? Is 12 a multiple of 3? Yes, it is. What do we do to turn 3 into 12? We multiply it by 4. 4 times 3 is 12, so we now have a family fraction of 12 for our denominator. And what we do to our denominator, we do to our numerator. 4 times 2 is 8. So we'll cross that out. This is our new fraction. 8/12ths, add 3/12ths, 8, 9, 10, 11 is 11/12. Shade the model to complete the calculation, and we've double checked to make sure we're right and used all our skills. Let's have a quick look at the last type of calculation. 4/6 add 2/30ths equals what? So it is one of these. So what's our common denominator going to be? Let's put 36 down here, but that can't be right because 36 isn't a multiple of 30. Let's have a look. Is 6, does 6 go into 30? Is 30 a multiple of 6? 6, 12, 18, 24, 30. Yes, it is. So we can keep this fraction and just change this one. How many 6's make 30? I'm going to put my new fraction over here. Oh, careful with my figures. How many times have I multiplied 6 to get to 30? I've multiplied it by 5. 5 times 6 is 30, so I have to do the same with my 4. 5 times 4 is 20. So my new fraction is 20/30ths. Add, I'm going to cross that out so I don't lose it, add 2/30ths, which gives me 22/30ths. And you know that you must make sure your figures, your digits are neatly drawn. Is this one of my answers? Yes, it is. Perfect. And what am I told to do? Circle the correct answer. And the evidence that I knew what I was doing is here. So they're the 4 types of questions you're going to come across this morning. Have a go, enjoy doing them. It actually is, I think, quite nice and straightforward today, and we'll look at problem solving tomorrow. Enjoy your maths.